You ever stop and wonder how your computer can juggle like a dozen different things at once? You're streaming a video, you've got tons of tabs open, you're running some heavy software, and it just works. It honestly feels like magic, right? Well, it all comes down to how it manages its internal workspace. So today, we're going to pull back the curtain and see how it all really works. So the big question we're tackling today is this: how in the world does a computer think so fast? The answer? Well, it's not just about its processor, its brain. It's all about its memory system. And the best way to wrap your head around this is to imagine a computer's memory as its workspace. It's this super organized system designed for one thing and one thing only: getting the right info to the processor at the right time. The better the workspace, the faster the work gets done. Simple as that. Now, just like a real office, this digital workspace isn't some giant, messy pile of papers. Oh no, it's organized into tiers. The easiest way to picture it is the difference between what's right on your desk in front of you versus what's tucked away in a filing cabinet down the hall.
Okay, so this brings us to our first really crucial distinction. You've got your secondary memory, that's the filing cabinet. Think of your hard drive for your SSD. It's great for long-term storage, but it's slow. The CPU can't work directly from there. It needs a high-speed workspace to hold whatever it's actively using. And that is why today we're focusing on the desk, primary memory. So, right there in that primary workspace, you've got three essential tools, and each one has a very specific job. There's RAM, which is kind of like the main desktop itself. Then there's ROM, which is like the permanent instruction manual that came with the desk. And then you have cache, the super fast sticky note for your most urgent thoughts.
All right, let's start with the biggest and probably most familiar part of this whole setup, RAM, or as we're going to call it, the volatile desktop.
So RAM stands for Random Access Memory, and that random access part is absolutely key. It means the processor can just jump to any piece of data directly without having to search for it in order. And that's what makes it so incredibly fast, and just perfect for holding all the apps and files you've got open right now. But, and this is a big but, here's the catch: RAM is volatile. Now that's just a fancy way of saying it needs constant power to hold on to its information. So when the power goes out, the entire desk gets cleared. Poof! Anything you didn't save to the filing cabinet, it's just gone. And not all RAM is the same. Most of our computers use something called DRAM, which is the workhorse memory that needs a constant electrical kick to hold its data. Then you've got SRAM, which is faster and way more expensive. It's built differently, so it doesn't need that constant refreshing, which makes it perfect for some really specialized jobs. And finally, there's VRAM, a dedicated type of RAM just for your graphics card to handle all that intense data needed to render beautiful images.
Okay, so if RAM is the temporary workspace that gets wiped clean, then what tells the computer what to do when it first wakes up? Well, that is the job of ROM, the permanent instruction manual.
ROM stands for read-only memory, and it's non-volatile, which is the complete opposite of RAM. It holds its information even when the power is off. It's got all the fundamental instructions written right in during manufacturing. Like the boot up sequence that tells your computer how to be a computer in the first place. And this whole read-only idea has actually evolved a ton. Originally, ROM was truly permanent, written once at the factory, and that was it. But then we got PROM, which you could program yourself, but only once. Then came EEPROM, which you could actually erase with UV light and reprogram. And now we have EEPROM, which can be electrically erased and rewritten, giving us all the flexibility we see in modern devices. Pretty cool, huh? Okay, let's move on to our final and fastest tool in the shed. If RAM is the desk, then cache is the lightning-fast memo. You can even think of it as a thought inside the worker's head. It's the secret weapon for getting work done at unbelievable speeds. Cache is a very small, very fast, and very expensive little piece of memory. It's often made of that super speedy SRAM we talked about. Its only job is to try and predict what the CPU will need next and hold that information right next to it, making it pretty much instantly accessible. So here's how it works in practice. To save precious time, whenever the CPU needs a piece of data, it doesn't just go running all the way over to the main desk. Nope. Its very first stop is the cache. It checks that little sticky note first. Now, if the data is right there, bingo, we call that a cache hit. And that is the absolute perfect outcome. It's an immediate, almost instantaneous retrieval that keeps the entire system humming along at top speed. But if the data isn't in the cache, what we call a cache miss, then it has to take the slightly longer trip to the main desk, the RAM, to find what it's looking for. Now, this is still fast, don't get me wrong, but it's a noticeable slowdown compared to getting a cache hit.
And how much slower are we talking about? Well, get this. Finding data in the cache can be up to 100 times faster than fetching it from RAM. 100. That incredible speed difference is exactly why this tiny piece of memory is so unbelievably critical for the performance of modern computers.
So, let's zoom out for a second and see how this all clicks together. It's really not about one type of memory being the best. It's about creating a perfectly balanced system, just like a busy, super efficient office.
So, next time you think about your computer's memory, just remember that workspace. Cache is the sticky note for your immediate thoughts. RAM is the main desk for all your active projects, and ROM is that permanent manual for all the basic functions. Together, they create this brilliant tiered system that balances the trade-off between speed, size, and cost to give the CPU exactly what it needs, exactly when it needs. Which kind of leaves us with one last thought. As we generate more data than ever before, think about AI models, virtual worlds, all of it, the demands on this digital workspace are only going to get crazier. So what will the computer workspace of the future need to look like to keep up? What new kinds of memory or new ways of organizing it all are we going to need?